Astronomers have captured a new image of the interstellar object 3I Atlas, and it turned out to be quite surprising. Instead of the usual signs of a comet, we see signs of chemistry that don't fit known models, along with a dusty cloud wrapping around its core like a tear. This is only the third interstellar visitor we've ever seen, yet it raises more questions than answers. Most importantly, scientists are not even sure they understand what they're looking at. So what did this new image of 3I Atlas reveal? Why does its composition and shape challenge our ideas about cosmic visitors? And how will ESA attempt to intercept this comet near Mars? Let's dig in. To make sense of it all, we first need to step back and ask, what exactly are these interstellar visitors? Throughout the history of astronomy, we've only recorded 3 objects arriving from another star system. The first was the famous Oumuamua in 2017, a cigar-shaped traveler with no visible coma that defied expectations and sparked fierce debate about its nature. The second was 2I Borisov in 2019, whose appearance was more orthodox, a classic comet with dust and gas, essentially an ordinary comet that just happened to wander in from another star. And now we have 3I Atlas, discovered on July 1, 2025, by the Atlas telescope in Chile. And once again, the rule book is being rewritten. How did astronomers know that 3I Atlas was interstellar? Its trajectory gave it away. It practically screamed outsider. It's making a one-time visit, moving too fast for the sun's gravity to hold it. In fact, when first spotted, it was traveling at over 130,000 miles per hour on a steep, almost backward-tilted path through the inner solar system. A hyperbolic orbit like this means it will fly by once and never return. As UCLA astronomer David Jewett puts it, it's like glimpsing a rifle bullet for 1,000th of a second. You can't project that back with any accuracy to figure out where it started. What we do know is that the object is ancient. Calculations indicate that it came from the thick disk of the Milky Way, a distant old region of our galaxy, which makes it possibly older than our own 4.6 billion-year-old solar system. Early observations show 3I behaving like a comet, a blurry cloud of gas and dust that forms from evaporating ice known as a coma. But even in this instance, it broke the pattern. It became active much farther from the sun than expected. Data from NASA's TESS spacecraft later showed the comet was already brightening back in May of 2025, when it was about 6 astronomical units away beyond Jupiter's orbit. Normally, comets don't switch on until they're much closer and warmer. That was the first hint that its makeup might be very different from other comets we know of. Estimates of its size have also shifted. Based on brightness, scientists first thought its nucleus could be between 3.5 and 7 miles wide, which would make it the largest interstellar object seen so far. The rest of what we see is its glowing coma. Unlike the elongated Oumuamua, 3I doesn't show big changes in brightness, which suggests it's more or less spherical. The story of 3I Atlas could have ended as just a passing visitor, but its looks and chemistry made it the most puzzling interstellar comet yet. Hubble and Webb both detected things we've never seen before in similar celestial bodies. The first big surprise came when astronomers pointed the James Webb Space Telescope at 3I to study its chemistry. On August 6, 2025, Webb used its infrared spectrograph to examine the comet's coma. JWST found that the fuzzy atmosphere was dominated by carbon dioxide. In fact, there was about 8 times more CO2 than water vapor. For reference, in most comets in our solar system, water is the main volatile that sublimates, while carbon dioxide usually plays a minor role. But here, the CO2 to H2O ratio is 8-to-1, making it one of the highest ever recorded. The only similar case scientists could point to was a distant comet named C-2016-R2, but even that wasn't quite as extreme as 3I. This rare and peculiar chemistry strongly suggests that 3I formed in an environment very different from our solar nebula. But how could a comet hold so much carbon dioxide compared to the amount of water? Scientists have a few hypotheses. One is that 3I formed near the CO2 ice line of its original star system, a zone far from the star where carbon dioxide could freeze. Another theory is that its ice was altered by radiation or stellar winds in its home system, changing its chemistry. Another possibility is that 3I has a thick insulating crust on its surface that traps much of its water ice inside. As the comet nears the Sun, only the more volatile ices like the CO2 and carbon monoxide can escape through cracks, while the water remains frozen until the comet gets much hotter. Theories aside, astronomers are watching closely because by late October 2025, 3I Atlas will reach its closest point to the Sun, a little beyond Earth's orbit, and it may reveal its true composition. Interestingly, by measuring the isotope ratios in the coma gases of 3I, researchers can get clues about its birthplace. In this case, the ratio of carbon-12 to carbon-13 in the CO2 is very similar to what we see in Earth's environment. That suggests that the material in 3I formed in a star system with a chemistry not all that different from the composition of our Sun. Paradoxically, it's both exotic in its high CO2 levels and familiar in its isotopic fingerprint. So did 3I form in the cold outskirts of a far-off system with a different balance of ice types? Or did it drift through the dark for eons with its carbon dioxide frozen solid, only to be warmed now by the rays of our star? The only way to answer that lies in the new image taken by Hubble, which we turn to next. While JWST was studying the chemistry of 3I Atlas, the Hubble Space Telescope focused on its appearance. Hubble captured a high-resolution image on July 21, 2025, when the comet was about 277 million miles from Earth. The resulting photograph is striking. Instead of a symmetrical halo, 3I is wrapped in a teardrop-shaped cocoon of dust around its core. It looks like a hazy, elongated glow with a bright head, as if the comet is spreading a broad fan of material to one side. Hubble confirmed that the dust is unevenly distributed. There's a wide plume of dust pointing toward the Sun and a much weaker tail stretching in the opposite direction. This is the opposite of the classic textbook picture of a comet. Normally, a comet's tail points away from the Sun due to solar radiation and the solar wind driving dust and gas outward. In fact, 3I does have a faint tail being driven away from the Sun. You can see some scattered material drifting outward in the images. But the dominant feature is the dust cloud facing the Sun. Astronomer David Jewett, who led the analysis of the telescope's data, noted that the object is clearly active and was already releasing dust heavily even when it was almost 4 times farther from the Sun than Earth. So, why does the comet appear to glow not only from behind but also from the front? The likely explanation is geometry and timing. 3I is racing toward the Sun at a steep angle, and when we observe it, we may be catching a large stream of dust blowing off the sunward side, similar to the beam of a car's headlights. Dust particles fly from the surface towards the Sun, then bend slightly under solar pressure, creating a broad curve of particles. Meanwhile, the classic comet tail is relatively weak. This unusual dust pattern may point to the possibility that 3I Atlas is approaching a star for the first time in a very long time. The image also helped refine the comet's size estimate. By analyzing the brightness distribution, Jewett's team set an upper limit for the nucleus at less than 3.5 miles across. It is likely smaller, possibly as narrow as a quarter-mile wide if most of the light is coming from the dust. For reference, the nucleus of 2I Borisov was believed to be about a mile across, and the nucleus of Oumuamua only 100 to 200 yards. A report from the Las Cumbres Observatory also noted that all three interstellar objects appear very dark and reddish, reflecting only about 5% of sunlight. This suggests that their surfaces are made of complex material rich in organic substances. Considering how much the comet's appearance has already amazed astronomers, imagine what will happen